As we sit on Earth, small and insignificant, we often think we know everything about the vastness of the cosmos just because we can illuminate a part of space with our tiny telescopes. Our computers calculate from observational data what's likely happening out there, physically and chemically. We reconstructed the stories of star formation, the movements of celestial bodies, and the universe's beginnings, and we call it science. Then, when a probe finally ventures where no man or machine has gone before, sending back data that could suggest something monumental, scientists dismiss it. They don't want to acknowledge the possibility of a new force of nature, perhaps one with its own intelligence, dwelling in the dark expanses of the cosmos. Voyager 1 and 2 are two of the most successful space exploration vehicles ever built, journeying far beyond the reach of any previous missions, photographing, measuring, and exploring the farthest edges of our solar system. In 2012, Voyager 1 crossed a boundary beyond the sun's influence into the mysterious interstellar medium. For the first time, human-made technology touched the infinite darkness of space. This moment was historic, as Voyager 1 became the first to venture beyond the heliosphere. Beyond the realm where our sun's radiation reaches lies a void of emptiness, untouched and unexplored. However, this space is vastly different from what we know closer to Earth. Space from the sun to beyond the Kuiper Belt is still shaped by solar radiation and magnetic forces. The true interstellar medium, the void beyond our solar system, begins billions of kilometers away. When exactly Voyager would reach this region was long unclear, but when it did, the probe sent back surprising data. Measurements showed unexpected magnetic forces, still present far outside the sun's influence, leading researchers to conclude that the solar force creates a stagnation zone before colliding with the interstellar medium. In 2015, the data shifted dramatically, making the transition to interstellar space even more tangible. While Voyager 1 continued to operate normally, it recently began sending puzzling data that suggested the spacecraft might be confused about its position in space. NASA initially reassured that this was expected in the later stages of the mission, attributing the issue to a problem with the spacecraft's attitude, articulation, and control system. However, despite the strange telemetry, Voyager 1 continued to send back data without triggering any alarms. This led some scientists to wonder if the data might be accurate and point to something beyond our understanding. Soon after, Voyager 1 detected a faint plasma current where there should have been nothing. While some explained it as the presence of fast-moving electrons, others believed this was another sign of something mysterious. The strange measurements and loss of space orientation hint at a new force in the interstellar medium, one we may not yet comprehend. Some researchers even dared to suggest that we might be encountering a new force of nature. They urged caution, warning against dismissing the unknown and unfamiliar. NASA, however, remained focused on addressing the probe's operational issues, going through decades-old manuals to find solutions. After troubleshooting, the team managed to resolve the telemetry problem, but the mystery of the strange data remains. As Voyager 1 and 2's power slowly dwindles, scientists hope the probes will remain operational until 2025. Voyager 1, currently 23.3 billion kilometers from Earth, continues to transmit valuable data about the properties of interstellar space. While Voyager 1 has flown beyond the heliosphere for nearly a decade, it still hasn't left the solar system completely. Farther out lies another mystery: the Oort cloud, a vast sphere of comets and asteroids bound to the sun. It will take Voyager 1 another 300 years to reach this distant region. Recently, the probe sent back cryptic data, confusing scientists with strange streams of particles in the interstellar medium. The mystery of what's happening beyond the heliosphere remains unsolved, but one thing is clear: we may be on the verge of discovering something far beyond what we currently understand about space. The interior of the solar system and life on Earth might not have been possible without the sun, which not only provides us with warmth and light, but also envelopes us in a protective cosmic shield. However, as shown by the Voyager probes, the sun's plasma streams do not extend into interstellar space. They stop at the boundary of the heliosphere. If scientists are correct in suggesting that a plasma stream originated from another star, it presents a challenge since the nearest star, Proxima Centauri, is more than 4 light-years away. This means the plasma stream would have traveled through interstellar space for over 4 years, which is impossible given the low particle density. For a plasma current to reach the heliosphere, it must either come from a nearby source or be driven by a powerful force. Whether this mysterious signal comes from a star or an unknown natural force in interstellar space remains uncertain, requiring further data and observations to draw conclusions. In 2021, Voyager 1 sent back data so confusing that scientists initially thought it had lost its orientation in space. The issue was resolved within weeks when they realized the probe's telemetry data had shifted, making it seem like it was tumbling uncontrollably. After the system was corrected, Voyager 1 resumed its grand journey through space. Something not widely known is that NASA wasn't sure Voyager 1 would even reach its first destination, Jupiter. The probe took a risky course through the asteroid belt between Jupiter and Mars, while Voyager 2 followed a slightly safer route, performing several planetary maneuvers. The probes were designed so that if one failed, the other could continue. In the 1970s, a rare alignment of the outer planets occurred, a chance that NASA had to seize as it happens only once every 176 years. Fortunately, both probes arrived at their destinations, with Voyager 1 reaching Jupiter in March 1979, just 18 months after launch. Voyager 1 provided stunning images and valuable data about Jupiter's atmosphere, its famous Great Red Spot, and the colorful cloud bands. It also made a groundbreaking discovery on one of Jupiter's moons, Io, which showed active volcanic eruptions, a first for planetary research. While Voyager 1 explored these phenomena, Voyager 2 followed close behind, reaching Jupiter in July 1979. Voyager 2 confirmed many of Voyager 1's discoveries and added detailed observations of Jupiter's rings and moons. The two probes worked together to broaden our understanding of Jupiter and its moons. After its successful flyby of Jupiter, Voyager 1 continued its journey, reaching Saturn in November 1980. There, it took the first close-up images of Saturn's rings and observed its atmosphere and magnetic field, with a special focus on its moon Titan, sparking interest due to its dense, foggy atmosphere. Voyager 2 arrived at Saturn in August 1981, adding further data to help clarify questions left from Voyager 1's visit. While Voyager 2 continued to Uranus and Neptune, Voyager 1 began its journey to the edge of the solar system. One of the most memorable moments in Voyager 1's mission came in 1990 when it captured the famous pale blue dot image, showing Earth as a tiny, fragile speck in the vastness of space. Although Voyager 1 was only about 6 billion kilometers away from Earth when the picture was taken, the image remains a powerful reminder of our planet's smallness in the universe. Carl Sagan, the astronomer who suggested the photograph, often emphasized how our small, yet beautiful, world is a unique treasure in the cosmos. Finally, in August 2012, Voyager 1. Voyager 1 became the first man-made object to cross the threshold into the interstellar medium, leaving our solar neighborhood and entering a region where the influences of the sun are gradually being overtaken by those of the galaxy. For nearly 12 years, Voyager 1 provided invaluable data. But then, an event likely marked the end of its mission. Despite NASA's successful efforts to resolve the telemetry issue in 2021, a new problem arose in the fall of 2023. The spacecraft transmitted data that was no longer comprehensible. A technician from the Deep Space Network identified this as an issue with the internal storage system, which holds the probe's data and movements. Unfortunately, NASA has yet to solve this problem, leading to the sad realization that communication with Voyager may first be lost for good, even though the probe will continue its journey through space. Voyager 2 also faced a crisis in 2023 when a routine check led NASA to send an erroneous command that caused the spacecraft to turn its communications antenna away from Earth. With Voyager 2 over 18 billion kilometers away, fixing the error was a monumental task. Signals took over 17 hours to reach the probe and equally long to return. Days passed without a signal, raising concerns that the mission might be lost. In a last-ditch effort, NASA sent a series of commands, hoping one would re-establish communication. Just when hope seemed to fade, a weak but unmistakable signal came from Voyager 2, confirming it had received and executed the command correctly. Relief swept through NASA's control center as communication was restored, saving one of the most distant man-made objects in the universe. In 2022, Voyager 1 also experienced telemetry issues, but NASA quickly diagnosed a fault in the onboard computer and resolved it with a command sent across over 20 billion kilometers. Both Voyager missions continue to operate, but scientists expect to lose contact by 2030 due to diminishing power. Voyager 2's 2018 crossing of the heliosphere, a boundary between the solar system and interstellar space, provided unexpected data. Scientists had long assumed the transition would be smooth, but instead, the heliosphere ended abruptly, like a solid barrier. This surprising discovery followed a similar one made by Voyager 1 in 2012, challenging previous assumptions about the structure of the solar bubble. The findings revealed that the interstellar medium contains more particles than previously believed, raising new questions for researchers. The heliosphere, a vast bubble of particles created by the solar wind, envelopes the solar system and separates it from interstellar space. The boundary between the two, called the heliopause, lies 10 to 20 billion kilometers from the Sun, with the entire structure stretching about 30 billion kilometers in diameter. The heliosphere is not static. It moves as a closed unit through the galaxy, with the solar system traveling at 828,000 kilometers per hour and the Milky Way at around 2.1 million kilometers per hour through the universe. In 1977, when Voyager 1 and 2 were launched, the timing was perfect due to a rare planetary alignment, allowing NASA to take advantage of a unique opportunity to explore the outer solar system. In the early 1970s, a researcher made an important discovery, noticing a unique alignment of planets. This alignment, which occurs every 176 years, meant that the outer planets, Jupiter, Saturn, Uranus, and Neptune, would soon line up perfectly. Normally, these planets are spread across different parts of the solar system, but during this rare event, they would be positioned close enough to one another that a space probe could visit all four with relative ease. Additionally, this alignment brought the planets closer to Earth, reducing the flight time to Neptune by 12 years. Recognizing this once-in-a-lifetime opportunity, NASA quickly designed and built two nearly identical probes, Voyager 1 and Voyager 2, on a limited budget. Both probes were launched in 1977, Voyager 2 on August 20th and Voyager 1 on September 5th, aboard Titan Centaur rockets, embarking on what would become one of the most iconic journeys in space exploration. Little did anyone know that more than 45 years later, these probes would still be traveling through space, setting record after record. After passing by Jupiter and Saturn, Voyager 2 used the gravitational pull of these planets to slingshot towards Uranus and Neptune. For the first time, humans were able to see the bright blue hues of Uranus and the deep blue splendor of Neptune, thanks to the images captured by Voyager 2. The probe also provided groundbreaking data, revealing the thin rings around Uranus, the violent storms on Neptune, and previously unknown moons of these ice giants. These discoveries were monumental for science. Voyager 2 will continue its journey for another 40,000 years, eventually approaching the star Ross 248, although it is unlikely to be captured by this system due to its small size and low mass. The probe will most likely continue drifting through the interstellar medium for thousands of years. Voyager 1, after making history as the first human-made object to reach Jupiter in 1979, provided detailed images of the planet's turbulent atmosphere, including the famous Great Red Spot. It also revealed volcanic activity on Jupiter's moon Io and gave the first indications of subsurface oceans on Europa. Voyager 1 then continued to Saturn, where it mapped the planet's rings and captured close-up images of Titan, Saturn's largest moon. These findings prompted further speculation about the possibility of Earth-like conditions on Titan. In 1980, Voyager 1 left the influence of the Sun and entered the uncharted territory of interstellar space. After a 12-year journey through the Kuiper Belt, Voyager 1 officially crossed into interstellar space on August 25, 2012, bringing new surprises. It detected strange particle streams, which scientists believe may have originated from distant events or even represent unknown forces. Voyager 1's data also revealed that the interstellar magnetic field was stronger and oriented differently than previously expected, challenging existing models of the galaxy. Voyager 1's remarkable longevity is nothing short of a miracle. Launched in 1977, it continues to function more than 45 years later, even after experiencing technical issues in May 2021 and again in November 2023. Both times, the probe transmitted confusing data, leading NASA engineers to work tirelessly to identify and solve the problems. Despite these setbacks, the probe remains operational, continuing its unprecedented mission to explore the vast regions of space beyond our solar system. The Voyager mission is one of humanity's boldest scientific endeavors, offering a unique opportunity to study interstellar space for the first time. As both Voyager 1 and Voyager 2 continue their journey into the unknown, the scientific community eagerly anticipates the data they will provide from these distant, unexplored realms. However, the mission faces two significant challenges: maintaining contact with the probes as they travel farther from Earth, and ensuring a steady energy supply from the diminishing plutonium-based generators. The future of the Voyager mission remains uncertain, but its legacy as a pioneering achievement in space exploration is already cemented. Most of the instruments on the Voyager probes were powered down to conserve energy for the most crucial scientific missions. NASA hopes that both probes will continue transmitting data until the end of the decade, or possibly beyond. Even when the radio link is lost, the mission will not end. The Voyager twins will become ambassadors for our civilization, each carrying a golden record with sounds, images, and messages from Earth. In thousands of years, these probes may be captured by a star's gravitational pull and perhaps be detected by another civilization. Voyager, fast, cheap, and reliable, was assembled quickly on a modest budget to take advantage of a rare planetary alignment. In the 1970s, Saturn, Jupiter, Uranus, and Neptune aligned in a way that would not occur again for another 170 years, prompting NASA to rush the construction of the Voyager probes. Launched in 1977, both probes successfully flew by these planets, providing groundbreaking data and images, including the discovery of volcanic activity on Jupiter's moon Io, and the first detailed look at Saturn's rings and its largest moon, Titan. Voyager 2 continued its journey, visiting Uranus in 1986 and Neptune in 1989, where it captured the first images of the planet and discovered its great dark spot. Both probes provided invaluable insights into the outer planets before their mission was extended to explore interstellar space. Remarkably, Voyager 1 became the first human-made object to enter interstellar space in 2012, followed by Voyager 2 in 2018. This milestone revealed surprising discoveries about the heliosphere and its boundary with interstellar space, including unexpected changes in the magnetic field and cosmic rays. The probe's transition into interstellar space astonished researchers, showing that the boundary between the heliosphere and the interstellar medium was far more abrupt than expected, forming a solid-like boundary rather than tapering off gradually. These findings suggest our solar system is encased in a protective sphere, shielding it from cosmic radiation. Voyager's longevity and resilience are a marvel of technology. Built on a shoestring budget, these probes have withstood extreme conditions for over 45 years. Key instruments, like the magnetometer and plasma science instruments, have provided vital data on magnetic fields and solar wind, deepening our understanding of both our solar system and the interstellar medium. Today, these simple yet pioneering probes continue to send back invaluable data, offering a glimpse into the vast, unexplored regions of space. Recent measurements have revealed that the magnetic field strength in space is stronger than previously thought. Despite these advances, the interstellar medium ISM remains largely a mystery. Interactions between different regions of the ISM likely play a role in star formation and the overall movement of stars through the galaxy. Now, shifting to the alien theory, Voyager 1 recently detected a dramatic increase in particles from the ISM. It was akin to a diver in the ocean suddenly spotting a strangely dense object. Naturally, the diver would be curious, wondering if it's a current, a school of fish, or even an unknown creature. Some researchers analyzing the data felt the same way. The sudden spike in particles and their unique signature didn't resemble anything random. Instead, it appeared to be the result of a special force, a mysterious energy, or perhaps even a living entity. This led some researchers to speculate that it could be something alive or a previously unknown natural force within the ISM. While these assumptions are not yet confirmed, we eagerly await what the Voyager probes will reveal in the years ahead. If you love exciting space content, subscribe to our channel now